Bright Tuty. Every student matters.
Write the following in decimal form and say what kind of decimal expansion each has. So, the first thing that you can divide these numbers using the long division method, otherwise you know that 36 by 100 means 0.36 itself. So, it is a terminating type of decimal expansion. Okay. What you can do is you can also show the working here. If you divide this number by 100, you will have a decimal here and then a 0 here, 300, then 60 is the remainder. So, you take a 0 here, 600, 0 is the remainder. So, this is the decimal expansion 0.36 and it is terminating type. And this also satisfies our assumption that verifies our observation that the numbers having denominators of the form 2 raised to power m into 5 raised to power n will have terminating type of decimal expansion. Now, look at this 1 by 11. So, we know that from our observation it will not be a terminating type of decimal expansion, it will keep repeating and the repeating block will obviously be less than 10 digits, less than 11 digits, right. So, 11 ones are 11, right. So, we will have a 0 here and a decimal here, it is still lesser than 11. So, we will have a 0 here and a 0 here. Now, 11 nines are 99, I have got 1 here, I started with 1, I have again got 1 here. So, now a 0 again, okay, and a 0 again. So, 9 again, okay, 99, 1 I have got. So, I can take a 0, but if I need to take another 0, I will have a 0 here. So, again 99. So, what I can say is 1 by 11 is 0.09 and 09 is the repeating block. So, it started repeating after 2 digits and this is 0.09 bar. Okay. What kind of decimal expansion is this? Non-terminating repeating. Okay. Look at this number 33 by 8, right. Some of you can do it directly also without showing the long division here, because it is not mentioned that we need to show the long division method. 33 by 8, 8 fours are 32, so 1 is the remainder. Now, a decimal 10, 8 ones are 8, so 2 is the remainder, once again a 0, 8 twos are 16, so 4, 0, 5, 40, now a 0 is the remainder, 4.125. So, this is 4.125, this is terminating type, terminating decimal expansion, and whenever I see terminating type of decimal expansion, I notice the denominator. Look at the denominator, it has got exclusively the powers of 2 only, it is 2 cubed, right. That is why it is a terminating decimal expansion. Now, this 3 by 13 will definitely be a non-terminating repeating type of decimal expansion. I am doing it directly here, 3 by 13. So, 0 point, now it will become 30 here. So, 2, 13 2s are 26. So, 4 is the remainder, 13 3s are 39, 1 is the remainder, a 0 here, 13 7s are 91. So, 9 is the remainder, 13 6 are 78. So, 12 is the remainder, 13 9s are 12 is the remainder, right. 13 9s are 117. So, 3 is the remainder. When 3 is the remainder, it will start repeating, because we started with 3 here. So, it will start repeating after this. So, this is the repeating block of numbers. Okay. Similarly, for 2 by 11, either you can try dividing it or you can multiply this by 2. Okay. So, this will be 810.18 and this is the repeating block. What kind of expansion is this? Non-terminating repeating type, and this is also non-terminating. I will write it like this: non-terminating repeating. Okay. Look at this one. This can be done directly. 329 by 400. If I divide only 329 by 4, it will give me 4 8s are 32, 4 2s are 8, 4 2s are 8, 4 5s are 20. So 82.25. Now I need to divide it by 400. So it will be 0.8225. It is a terminating decimal expansion, right? It terminated after 4 digits. Why? Because the denominator exclusively has the powers of 2 and 5 only, right? So this was about this question. Let's look at this one. You know that 1 by 7 is this. Can you predict the decimal expansions of 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7, etc.? Yes, we can easily do that. Why? Because if we have got 1 by 7, 2 by 7 is nothing but 2 into 1 by 7. So, I will just multiply this number by 2 and find the value. 2 by 7 will be equal to 2 7s are 14, 1, 11, 1, 16 plus 1 is 7, 1, 5. So, this will be the repeating block. I would like you to multiply it yourself, because when I speak, when I am multiplying, I may not speak every step of multiplication, but this will be the result of multiplication. Okay. So, what I have done is I have just multiplied this number by 2. For 3 by 7, I will multiply this number by 3. So, this will be 0.428571. Similarly, you can find 4 by 7, 5 by 7, 6 by 7, etc. Right? You keep on multiplying these numbers and you will find the answer. So, this is how you can find these numbers without actually performing the long division. Okay. So, rest of the numbers 4 by 7, 5 by 7, 6 by 7, I want you to do yourself. 4 by 7, what you can do is you can multiply this number by 2. For 6 by 7, you can multiply this number by 2. For 5 by 7, you can multiply this number by 5. Okay. Express the following in the form of p by q, where p and q are integers. First number, let us take it as equal to x. So, let x equal to 0.6 bar, multiplying both sides. By 10, I will have 10x equal to 6.6 bar, right. Subtracting 1 from 2, I will have 9x equal to 6, right. So, x will be equal to 6 upon 9. Okay. Next one is 0.47 bar. So, for this one, I will assume x equal to 0.47 bar. First thing, I will bring this non-repeating digit on the left. So, 10x is equal to 4.7 bar. Now, I will multiply both sides by 10. So, 100x will be equal to 47.7 bar. Now, this is my equation 1, this is equation 2. I will subtract 1 from 2. So, I will have 90x equal to 47 minus 4 is 43. And repeating block got eliminated. X is equal to 43 by 90. This is the decimal expansion. Otherwise also 47 minus this non-repeating, that is 43, divided by 9 for this repeating and 0 for this non-repeating. This is the shortcut that I told you in the previous questions also. Okay. You can always, without performing any of these calculations, you can write this number directly. How? This number 47 minus this non-repeating digit 4 divided by number of repeating digits 1, so 1 9 here. Number of non-repeating digits 1, so a 0 here. So this will be the same p by q form here. Next is 0.001 and 001 is the repeating one. So let's do it here itself. Let, this is the third part. Let x is equal to 0.001 bar. Now I need to eliminate this repeating block, so I'll multiply this number by 1000. So 1000 x is equal to 1.001 bar. Okay. Now if I subtract these, I'll have 999x equal to 1. So x is equal to 1 upon 999. Okay. And this can also be done using the shortcut, because I do not have any known repeating digit on the right hand side. So I'll simply take this number 1 in the numerator, and the numbers, how many numbers are in the repeating block? 3. So 3 9s in the denominator. Express this number in the form of p by q. Are you surprised with your answer? Let us see what is the answer. If I write x equal to 0.999999 and so on, I can write it as 0.9 bar, right? Now if I multiply both sides by 10, I'll have 9.9 bar here. Okay. Now if I subtract 1 from 2, I'll have 9x on the left hand side, and on the right hand side I'll have 9. So x is equal to 1. Okay. We started with the assumption that x is equal to this number, which is 0.999999 and so on, but when we wrote it in p by q form, it is just 1, right? Are you surprised with it? No, because it has to be equal to 1, because when you keep on writing 99999, you don't know where will you stop, right? This number is, if you write only this 0.99999, this number is very near to 1. Okay. But when you keep on increasing these 9s, it reaches to 1, right? And if you keep continuing like this, then it will be exactly equal to 1. Now this is equal to 1, this is not smaller than 1, right? If someone says that a number just smaller than 1 is 0.99 or 0.9 bar, this is wrong, because this is not smaller than 1, this is equal to 1, right? We saw it here also, right? We didn't skip any step, our process was not flowed, right? Our process was flawless. So we reached at a neat answer, which is x equal to 1. Hence we can say that this number here is exactly equal to 1, it is not lesser than 1, right? What can be the maximum number of digits in the repeating block of digits of the decimal expansion of 1 by 17? So maximum digits can be, maximum digits in the repeating block is 16, right? Lesser than the divisor. Divisor is 17, so the maximum number of repeating digits will be 16. Perform the division to check your answer. So you will have to perform the division to check your answer. So 0 point, I will have a 0 here, but it is still lesser than 17, so a 0 again, I will have a 100 here, and then 5, 85, so 15 will be the remainder, a 0 here, right? 8 will give me 136 here. So 14 here, right, and a 0. So I'll have 8 again and 136 here. I'll have 4. So again 0. 17 2s are 34. I'll have 6 here. So 0. 17 3s are 51. So I'll have 9 here. Okay. So 9 is 0 here. 17 5s are 85, 5 here, so 50, 2, 34, 16, okay, still it will not start repeating, because the remainder, if I get the same remainder as in the previous steps, then it will start repeating. Okay.